Mastering list summation in Python.
My name is Mohammed, and coding alongside me is.
It's George, and today we'll be going over mastering list summation in Python. You take it, Mohammed?
So basically, a lot of people, whether they're at a beginner level or the intermediate level or the advanced level, a lot of them have this very simple question: How do you do summation operations uh, in Python for lists, like in lists in particular? And you might be surprised to know that most people Google this question on all three levels. A lot of people might know this, a lot of people might not know this. So to make sure that we can clear up this question on our channel, uh, we're going to go over the concept. Now, there are multiple ways you can do summation operations on lists. Most people just go over one of them, but in our video, we're going to go over three of those methods. And the reason being is that two of those methods have the flexibility to handle multiple numeric operations that you want to do, not just summation operations. But one of the function is just as the summation operation. But it has power that it's very simple to understand and use, and it is very easy to implement and very short. You can just implement it in one line of code. But we'll start with the most basic method that a lot of people at the basic or intermediate level use, which is a simple for loop. So you'll already be familiar with for loops. I'm not going to go into much detail about how for loops work, but the basic gist of all the code that I'm going to show you in the next three files is a function that does the summation operation, an example usage where we define the list. We create a variable called result that stores the value of the function that we create to do the summation operation, and then we print that statement with the result and mentioning which method was used to calculate or tabulate that result. So if you look at lines 9, 10, 11, usually at the end of my file, we'll have the example usage part, which will be creating the example list, the result variable that stores the result value from our function, and the print statement. So we're not going to go over that. What we're going to be focusing on is the function that we create and the method we employ in the function to do summation operations. So the first method is uses a for loop to iterate through a list and accumulate the sum. So again, it's a very simple method. I'm sure a lot of you would be familiar with this, even if it's not coming from coming to you at the top of your head immediately. Is in line 3, you could note that we created a accumulator variable, which we assigned the value of 0. What this would do is that as we loop through each value in the list, we'll add that value within this result variable, which ultimately by the end of the loop, when the last value would be added and the loop exits, we'll have the entire sum of the list. So for that, you just create a simple for loop like we did on line 4 and 5. For num in my list, result plus equals to num, a simple use of syntactic sugar in Python, and then we return the result on line 6. It's as simple as that. So when we run this script, we get our right answer. Sum using for loop is 15, right here on our console. Now we close our console and move on to the next method that you could use to do summation on Python lists, and that is leveraging built-in sum function, which is probably the most concise and efficient way to just do summation operations. You can do it in one line. If you could, you can do it in one line compared to the 4 to 5 lines we have written down here to do the for loop. And it might seem kind of excessive to have, to say that there's a big difference in the amount of code that has been written, but these things tend to add up when you are coding large or big programs, And it's just 4 lines here for a simple summation operation. There will be more complex numeric operations that you might do just in addition, just in summation operations. And at that point, this code could become very, very complex, very, very quickly. So for that, you can just use a simple sum function on Python, which is a built-in function. If you look, our entire function takes two lines, defining the function and then returning the value, which, the entire logic just takes 1 line. Return sum my list. That's it. That's all you need to know. Simple, easy, efficient, concise, and you can do your summation operations very easily. We run the script. The example usage that we deployed here is exactly the same as the previous one. We'll get sum using sum function 15. That means the result is exactly as it should be. Now, a very, very huge drawback about the sum function is that it cannot handle anything other than a summation numeric operation. So if you want to do if you want to add values in a list, it's quite easy. You just pick up the list, put it in the sum function, and you have the result. Like, it's very, very easy, very, very quick to use. But in case you have to do other operations, subtraction, multiplication, division, or any other complex numeric operations, then the sum function cannot be used, and you probably need to use the for loop. But here's the thing. What if I tell you there's a function that's equally as concise, but can do much more flexible operations, numeric operations, just like the for loop? But the catch is, it's slightly tricky to get a handle on. Once you understand that, you can do any sort of numeric operations in 1 line quickly and efficiently, unlike for loops. So if we go to our file number 3, you'll see there's a tool that there's a function within a module that we use. In the func tools module, there's a function called import reduce. So we import that on line 1. Then in our function that does the summation operation, we just return the value of the reduce function acting on that list. Now, the reduce function is fairly complicated because there are 3 input values to the reduce function for it to function properly. And understanding that is a little bit not complex, but it's a little bit tricky to get your head around. So the reduce function takes in 3 arguments. It takes a function, it takes an iterable, and it takes an initializer. But before we go into the arguments, we need to understand what does it mean by why did we call this a reduce function? Because the naming of a function tells us a lot about the purpose of the function. So the reduce function does a single thing. It takes a collection of values and reduces those values into a single value. Let me phrase that again. It takes a collection of values and reduces that into a single value. Now, how does it reduce that value in a single value? The first argument called function. What it tells the reduce function is apply this numeric operation on this collection of values to reduce them to a single value. So if you look at our reduce function on line 5, we have defined a function that tells the reduce function to do a summation operation. We can do a multiplication operation here. We can do a division operation here. We can do any manner of complex mathematical operation within this function on a single line to reduce the list into a single value. And here we define the function as lambda, x, and y as our variables, and then after colon we define the operation, which is x plus y, a simple summation operation. Then the second value in the reduce function is the iterable, which is what are the collection of values do you want the reduce function to act on and reduce into a single value? That is our list that we're going to be acting on. And the third value is the initializer. What is the initializer? If the gist of the initializer is that if you have 5 values in the list and this function acts on them, Initializer is the additional value that's going to act on top of that. In most cases, you can just place it as 0 because you don't want any adulteration of the results that you're tabulating. So simply add 0 there, or unless you want to add some sort of additional number to that result, then you can specify that number like 10, 5, whatever that number being. But in 90% of the cases, you don't need to adulterate the results from the list or any other play iterable that you're taking the value from. So basically, that is all there is to the reduce function. If you understand that, it is probably one of the best tools that you can learn out of this video today, because it can help you do so much just on a single line. That's how powerful this function is. While it might seem a little too complicated for a simple summation operation, but remember, we're not learning this just for one thing. You don't learn coding functions, or you don't learn encoding just to do one specific handle one specific problem. You need to understand and to leverage different strategies to cope with multiple scenarios, and here it helps us tackle with or more complex numeric calculations. While you might say a for loop can do the same thing, but for loop would become very complicated very quickly when you're dealing with higher, more complex numeric operations with just not addition, subtraction, division, and multiplication. So in that case, the reduce function is probably your best bet to leverage. The sum function is very concise and to the point, but it's not flexible enough if you're dealing with anything other than summation operation. So having said that, we'll run this script as well to see if it's functioning fine. If you look at the console, I'm highlighting the results here. Sum using functools.reduce is 15, so it's working fine. So do simple checks when you're one last thing is to do simple checks when you're leveraging the reduce function, just to make sure that your function is performing as it should. Just a few sanity checks on different values, with expected values having been calculated before, not on the program, and just to make sure those values are as they should be to test out your function. But if that is the case, then this function is probably the most flexible and most concise. It's the best of the both worlds. It has the flexibility of the for loop, and it has the conciseness of the sum function. And with that, I'll wrap this video up. Anything you want to add, George, before we wrap up our video?
No, I think you covered all the points, Mohammed. Just like and subscribe, and leave comments to suggested videos in the comment section. Thanks, y'all.